Welcome to Partner Point of View, where we sit down with PTC partners and discuss how together we innovate, collaborate, and unlock power by the convergence of physical and digital worlds.
Hello and welcome to today's Partner Point of View, Improving Product Sustainability. My name is Dave Duncan, and I'm the Vice President of Sustainability here at PTC. I'm joined by Chad Markle, Global Commercial Lead, and Aaron Schaefer, Manager, both from Kalypso, a Rockwell automation business, as well as Alex Saunders, Worldwide Sustainability Partnerships Leader at Microsoft. Today, we're going to dive into why sustainability has become a top priority across industries, the ways manufacturers could become more sustainable, and so much more. So let's get started. So sustainability is an emerging field, and it's been very noisy, frankly, for manufacturers. And what we want to do today is boil down the values that manufacturers need to provide for sustainability. And rather than be academic about our discussions, we want to talk about what real customers are doing to move the needle on sustainability. So when you hear about sustainable products or circular products, that can be greenwashing to some extent. For those of us in manufacturing, we know that it's more of a spectrum. We want our products to become more sustainable. They're not going to be perfectly sustainable overnight, and probably not even within a decade, but we can move the needle significantly. Likewise on its circularity. So what we're going to do today is do some storytelling about what we're seeing with our customers and what they're doing to move towards that sustainable and circular spectrum in their products. And we'll focus on three areas of the product lifecycle that manufacturers can have the most impact on. So we'll start up front with design, then we'll move to manufacturing, and then we'll move to service. So first, I'll start with Chad. So Chad, for the design phase of the product lifecycle, what are you seeing that's out there in the field that's making actionable improvement on sustainability?
First off, Dave, thanks for having us. Excited about the conversation today. It's a very important area in terms of design because it turns out that R&D drives 5% of the cost of a product, but has 80% of the impact in sustainability. So we're talking about the important heroes and really driving the impact that we would like to get in sustainability. It's interesting, though, the challenge is once you start going in and looking at the product from a new lens about driving sustainability, because certainly designers and developers and R&D people have thought about the need to drive process and performance and cost and quality, and now we need to factor in sustainability associated with it. And it drives you in some complex situations. We're part of Rockwell Automation, a leading automation and controls company, and we manufacture products, well known for our PLCs, drives, and motors. Our customers expect us to, and we think the imperative is to be able to drive better products and more sustainable products. But to be able to do that, we add technology often. So there's complexity associated with driving a variable speed drive. You're talking about adding sophisticated electronics, semiconductors, sensors to be able to do that. So to be able to do that, it requires information, knowledge, and tools associated with it. So we see an upskilling in terms of the tools and capabilities that are necessary for R&D to do it, and a knowledge and an understanding of what's possible associated with it, which means a lot of collaboration either within the company or outside the company around new ideas. Very exciting time, very challenging for our designers, developers, and R&D people to be able to deliver on this.
Great. Yeah, we're seeing the same thing. I mean, sustainability is not a one-vendor sport. There's so much data that's upstream in the supply chain that's needed to make good design decisions. So we're seeing the same amounts of collaboration that needs to be done among partners.
Aaron, do you have an example you'd like to share?
Sure. I can speak to a packaging example. So global packaging provider came to Rockwell for more traditional reasons, seeking partnership on technology and implementing informed and more improved processes, but ultimately it became a play about reducing waste. So they're looking for 100% of their packaging to be designed or at least advanced and improved to be recyclable, reusable. They're seeking 50% reduced waste at end of life with packaging. So a huge part of a product that doesn't necessarily add value to a consumer experience with that product, but contributes to so much of the waste and ultimately the sustainability metrics. So Rockwell was able to partner with that organization to make extreme improvements in their overall sustainability for providing packaging to other companies.
Yeah, great comment. I mean, in the bill of materials, packaging hasn't been a focus of discussion, but it is now more than ever because it is the most visible and avoidable waste stream from the products that we manufacture. So an early win for a lot of customers is focusing on that packaging portion of the bill of materials and dematerializing that as much as possible, and also working to use recyclable content. Now, going to you, Alec. Alec, what are you seeing at Microsoft from your customers around the design phase and sustainability?
Yeah, very, very similar kinds of things. You know, I was struck earlier this month when I sat down and I looked at our last quarter numbers and saw that almost 40% of the business that we'd done in the last quarter that was sustainability related was actually about supply chain characterization. It was trying to find higher quality, more sustainable inputs from different vendors. And so customers everywhere are diving into that one, particularly ferociously right now. They're trying to figure out what it is that they need to do in order to be able to build more sustainable products. And then, you know, from a customer perspective, we're seeing all kinds of opportunities popping up here and there. One of the ones that we're working on really hard right now with an automotive manufacturer is around battery characterization. How do you build more sustainable batteries as we move into this world of electric cars? And how do you characterize the inputs and the provenance of the different minerals that are going into those batteries? And then what do you do with them at the end of life of those batteries? So initiatives like Battery Passport are starting to turn that into a regulatory framework that manufacturers will have to comply with. And in the meantime, the manufacturers that are producing these products are getting out in front and trying to figure out how it is that they can produce products that will really meet that mark. And I just want to throw in one other comment. You know, regulatory we're seeing as an increasingly important driver of these things, whether it's the desire to be able to characterize individual products at the serial number level according to sustainability characteristics, which is coming into regulations across Europe, or whether it's being driven by other factors. We're seeing this on a repeat basis, this need to be able to get down to the level of the product itself and characterize that.
Good. Thank you, Alec. And yes, we're seeing compliance and regulation being a big deal as well. You know, at PTC, I had a customer tell me that they're finding on average 20 new regulations having to do with sustainability per day from the various regions that this global manufacturer needs to play in. The EU has regulations, the United States through SEC and other boards, as well as standards that buyers want companies to comply with. We met with a customer and a system integrator in Germany recently who has developed requirements packages, if you will, that are reusable among manufacturers. They're starting to curate not only best practices, but also thou shalt do requirements in requirements management systems, which then design engineers can use through OSLC tracing to link their designs to those requirements and likewise to their tests and other design artifacts so that from all the way upstream, from product management to the final verification, you can ensure that your design meets the sustainability requirements that you've been given. The other thing that these knowledge packs do as well is that it's not a burden for each manufacturer to keep up with it if you subscribe to such services where they keep up with the different standards and the best practices and put those in your starter packs, if you will, for requirements. So as far as when we get beyond requirements and into the actual design, three areas where we see focus for engineering are around dematerialization, which is one, using the right material. That doesn't come with a lot of embodied carbon, of course, is REACH, ROSE approved for hazmat and other aspects, but also using as little of that material as possible in your design. One, to save material, and you get a double bonus if it's on a mobility device because it removes the energy that's needed to operate that product. So dematerialization's a big one. Energy efficiency, of course, as Chad and Aaron have mentioned, and also waste reduction in that not only using recyclable material, but also designing for disassembly. So that when the product is end of life, that larger components of that product can be removed and recovered either back in a supply warehouse or remanufactured, or maybe some material does need to be recycled beyond that. But an example of a company that is putting all three of these to a practical practice is an engine manufacturer is using generative design for some of their heavier components on the engine. And they've developed this optimization culture at in their engineering department, where they encourage the use of advanced simulation as they're doing their designs, and lightweighting and dematerialization is one of those that they do with generative design, but also running other simulations that can be run as a quick subroutine and return some information back in a design engineer's language to help them make informed decisions up front. And they gamify it a bit as well. Like one example that they gave is for a particular truck engine, they removed enough material off of a supporting structure that it was the equivalent of taking 1,000 F-150 trucks off the road for the expected use of the engine. And that's like a real feel-good that an engineer can go home and tell their family about. So there's a lot of personal desire to do this, and now there's advanced simulation methods that can be run as subroutines from your home system of either CAD or PLM to do these things. Okay, so there's much more we can discuss in design, but those are some of, I think, the early high-impact adopters that we covered among the three of us. Now, I'd like to transition into manufacturing. And as we transition into manufacturing, the bridge between design and manufacturing is manufacturing process planning. An area of focus that we've seen from our customers that help with sustainability is with the process plans that are derived with manufacturing engineering, with the attitude of, hey, I can design anywhere, but I can also build anywhere, so that I can nearshore my manufacturing. That removes a significant amount of embodied carbon in the transport of the materials to do the assembly, as well as the transport to where the customer is, not to mention landed cost and other financial benefits. But as we dip into the factory, and what do we do specifically within the walls of the factory to further improve sustainability? Aaron, I'd like to get your take on what you're seeing at Rockwell and Kalypso within the factories.
Absolutely. Within the factories, I would say energy management is the term that has kept us very busy recently, especially with heavy industry like steel or tire, for example, like equipment that's using a ton of energy. And energy is, as we define it, wages, water, air, gas, electricity, and steam. So beyond just seeing what utilities are going into a facility, it's seeing where those resources are used within the four walls as well. So being able to give a client that sort of perspective on where they're using utilities. Is their utility information matching up with their production data? Are they using utilities on days where production is low? And are there ways to better optimize the lines that they're running to see high performing? So we're seeing that especially right now in food and beverage. So I'm working with a client that is producing bottled beverages, sometimes carbonated, sometimes not, but they're trying to do so in water scarce areas. So obviously, water is a huge ingredient when you're producing a bottled beverage. So ensuring that there's proper monitoring of their water consumption and working with their local cities and municipalities to make sure that their consumption is tracked really closely so that they can do that future scaling to be able to still provide the product that they are known for and loved for.
Yeah, that's interesting. Like we always think of energy efficiency as electricity and gas, but it's so much more than that. Like water is a huge issue in a lot of regions of manufacturing as well. Like retail, it's big with cotton and certainly big in process industry. Also in discrete to a large extent. Water is used in manufacturing. So thank you.
If I could build on what Aaron was just talking about, once we have an understanding of the energy footprint of the organization and where it's being used on a real-time basis, we are now finding norms that we thought would be true. For instance, a lot of the energy consumption, on average 50 to 60%, is driven by motors in facilities. So now it comes into what are the strategies we can do to address those important consumers that really drive the production process. And we're seeing, certainly efficiency is important to make sure that for the speed and torque of that particular motor, that we've got the right nameplate and the efficiency, and technology's advanced quite a bit. And so new motors are much more efficient and can, a 6% increase in motor productivity will pay for itself in 2 years. So we're seeing efficiency gains. We're seeing variable speed motors, variable speed drives being implemented so that there's the power you need, but only so much, and you can reduce idling and really fit to the purpose associated with it. And then we're seeing it allows also to look at the line from an overall line standpoint and model and simulate that, often using digital twin technologies, of which PTC contributes importantly to that. And so that you can actually now reimagine what exactly are line lengths associated with it, making sure that when a belt runs, it's running continuously with product, and reimagining how that line could operate for efficiency. Now that we have the technology and the impetus associated with it, and we can measure in real time. And a lot of the new products, certainly Rockwell products, will actually give you the information real time from the machine, so you don't have to guess about it, and you can understand and make sure that you're operating at an efficient level with HMIs that are right at the point of impact.
So they design it with like the efficiency iteration intent.
Indeed.
They do that up front with the design, with the sensors and the types of calculations.
Indeed. So the good news is we're arming the front line in production with the right tools associated with it, and the gains are significant. The opportunities are really exciting.
Nice, excellent. It sounds like you've chosen the worst offending energy users, right? Which are the motors.
That's right.
So starting there on
That's
the
right.
Paretos. Fantastic. So Alec, at Microsoft, I know that you do a ton in manufacturing as well, and get down to some of the specific measures of emissions as well within manufacturing and operations. And if you could shed some light on, what some of the important considerations and measures are there, and what you're seeing with your customers in manufacturing or in the factory.
One of the things that we spend a reasonable amount of time actually with customers on is just the basics of what are scope 1, 2, and 3 emissions. And if you aren't familiar with those terms, scope 1 is emissions that are produced from fuel that you consume. You burn diesel to run your manufacturing process. You burn coke to be able to run your steel process. The emissions associated with that are your scope 1 emissions. Scope 2 come from somebody else creating those emissions and then delivering energy to you. So electricity or heat from a third-party provider. And scope 3 are all the things that come up and down the supply chain and the value chain. So anything that has to do with inputs into your business and outputs from your business as you take your products to market. And it's scope 3 that's really the knottiest problem to solve. So to build on some of Chad's comments earlier, we're just seeing really digitization occurring throughout the manufacturing process. One of our customers recently went through a process with us to do a whole bunch of work to create AI-driven thermal imaging to measure the outputs from heat exchangers. Heat exchangers and lost heat accounts for roughly some say as high as 2.5% of emissions from manufacturing processes. So if we can make those better, then we can solve a pretty significant emissions process. Digital twinning comes up all the time. The ability to map out what's in a facility and understand how it's operating and simulate different ways to operate are pretty critical things. And the data exhaust that comes from those can then be used to as inputs into AI processes to improve the operations of the plant. And again, one of our partners is taking data out of these processes and running them into a model they built, an AI model that gives most customers between 6 and 8% improvements in emissions simply by optimizing the processes on the factory floor. A really good example of that, we're working with a paper pulp and paper manufacturer right now, and what we're doing with them allows them to more quickly do changes on the floor, so that they have, rather than relying on guesstimates, and so they have less waste, and they end up having less emissions. They run their business more profitably because they're using more of the input products as well. So lots and lots of different ways you can approach what's going on in the manufacturing process. And I think there's just depending on the business, there's a huge number of possibilities for how you can optimize it. And as I would agree with Chad and yourself, zero in on the biggest consumers and the biggest energy, or sort of the biggest emissions, the biggest emitters to start. That's the best place to get started.
Great, thank you, Alec. And completely agree. Like a lot of what Aaron and Chad and Alec talked about were new ways to get measures about what's going on in the factory. But it's ultimately humans that are making the most innovative decisions about how to resolve those issues and improve sustainability in the factory. And what the data allows you to do is take a practical approach with whatever data is available, help identify what the bottlenecks are for sustainability or other problems in the factory, and from that make a prioritization. So censor up the 3 machines out of 50 that are causing you the most pain, identify what those issues are, and then use human decision-making informed by that data to improve that, remeasure it, get a new improvement. That's not your bottleneck anymore. Find the next one and iterate improvement that way. We've seen using that bottleneck analysis and iteration at both process manufacturing as well as discrete manufacturing. In process manufacturing, we've seen OEE improvements of up to 13%, fairly quickly by running through the first iterations of the bottleneck. And in discrete manufacturing, we had a company that improved the first pass quality inspection from 75% to 98% by going through 6 or 7 of those iterations, which reduced a fantastic amount of waste by doing so. And they continue to run that. It's something that's just ongoing. Like you're always trying to get better and then meet your objectives. So on to, I think, our third and last life cycle state that we'll cover today, which is service. And historically speaking, most manufacturers don't do service directly. Like they typically sell through a dealer or retailer, and then that third party provides service, and that's still continuing. But there is a spectrum that goes anywhere from, hey, aftermarket is completely through distributor networks and dealer networks, to product as a service, like an aircraft engine where everyone except for the OEM is hands-off through the life of that product. And with sustainability and the desire and increasing regulation to responsibly end-of-life the product, there's more and more regulatory pressure to have commercial arrangements that are a bit tighter, where the OEM has more control over the product after it's sold all the way to the end-of-life date. So that's one aspect of service. And then the other aspect of service is there's always still is some liability for the manufacturer, whether they sell just a base warranty or an extended contract, or they're leasing to provide efficient service, identify the right problems, only fix the parts that need to be fixed, items like that. So maybe I'll start with you, Chad. What are you seeing out in the field as far as things that people are doing to improve the sustainable service of durable assets?
Yeah, Dave, great setup in the area of service. And we think the adage, and even my clients would say in the industry, the best service is no service and sustainability, right? Avoiding truck rolls and costs associated with it. And so definitely an emphasis has been true, and even more so now, is smart connected products, where there's the capability of the field service to understand an intelligent product and how it's being used in the marketplace. What are the failure modes as they roll up on it? What exactly, if they need to, what are the parts that they need to address it? If they can avoid and remotely fix it, then that's so much the better. And so we see an emphasis there. We see also, with some of the field force and automation capabilities, ability to set accountability for how the equipment should be disposed of and managed. So if there's There's particular materials that need to be repossessed if the machine is being turned down, pulling out things like cadmium and lead and nickel. There's an efficient disposal process that's actually built into the application, in applications like ServiceMax, which is, congratulations on the acquisition, by the way, great application.
No, thank you. Yeah, helps with dispatch optimization and many other levers for servicing products.
It does, and I think it's important to have that capability because also it provides a closed loop feedback system. So one of our clients, which is a major EV manufacturer, does service their own vehicles, and the techs are able to give feedback on what they're seeing in terms of the vehicle performance or what they're fixing. That's flowing right back to R&D, and they're able to ensconce that in future designs to be able to address it. So the only way you can do that is through really effective collaboration technology that's set up at the point of impact to feed that back to the organization.
All right, so they're designing from service from the get-go.
Indeed.
Have really good feedback loops to make noticeable improvements for the next evolutions.
Indeed.
Fantastic.
Yep. So, and the other one example I would use is we're working with a number of electronics manufacturers, and there's a lot of e-waste that tends to be generated, and I think the viewpoint is, they're short-lived assets, technology is moving so quickly, and there's 60 million metric tons of e-waste that's out there every year, and it's increasing by 2 metric tons a year. So we really need to get on top of this. And we're seeing with the design and collaboration tools, back to the beginning of our conversation, the ability to design those so that they can be remanufactured or disposed of appropriately, so the service personnel now has a product that they can go to work on in the field to go and fix it in an appropriate way or dispose of it in an appropriate way. So, designing for service, as you said, is a really important element in that industry.
Right. Alec, what are you seeing at Microsoft for sustainability improvements in the service lifecycle?
Well, yeah, I actually want to build on Chad's thoughts about designing for serviceability. And it's not an example that is a customer example. It's actually Microsoft itself. We run the largest network of data centers around the world. And every data center has a circularity center associated with it. And we reclaim as much as we possibly can from the components that come out of those data centers. Data centers have servers that fail all the time, processors and whatever else. And we work very hard to make sure that we reuse those pieces as much as possible. And it's had a huge impact on our business. And so when we go out and have conversations with customers about this and with partners about this, it's often an example that gets used. We're seeing some really exciting things in the manufacturing space as well. We're seeing some pretty interesting experiments going on with pyrolysis around hydrocarbons and seeing how those can be used to return back to their constituent components and reused to make plastics again. We're seeing packaging reused as well. So there's some pretty exciting stuff coming. And to tie it back to the earlier comment that I made around different emission scopes, now you can account for, in most emissions calculators, emissions that are associated with the disposal of waste as well. So not only is serviceability an incredibly important piece of it, but it's going to also start to show up in your emissions disclosures as you are more and more required to provide those to different bodies, and serviceability is going to show up indirectly as an emissions impact if your products aren't serviceable. So everybody's interested in this.
Yeah, we're seeing the same benefits with Azure hosting and our SaaS offerings as well. We can help our customers remove their on-premise data centers and the burden of having to deal with their e-waste by going to a hyperscale data center with Microsoft, which is on a really aggressive track for not only using renewable energy, but also getting closer to zero waste in the life cycle of the hardware and infrastructure that they use in their data centers. So that's it's a material improvement in the software offers that we give our customers. So it's a great example. So we talked a lot about the circular aspects and the return of material and the different models that are used for that. And it's still a fairly less mature area that requires a lot more work, and there'll be a lot of innovation. I think we have some follow-up sessions there. But maybe to wrap up the service aspect of this discussion, just rounded out with a couple other dials that you could potentially turn on service is particularly for long life cycle pieces of hardware that you need to service that are complex. You want to avoid as much as possible having to put a subject matter expert on a plane to go service that equipment. Or if you do, you want to make sure that you fix it correctly the first time. And part of the issue is that you have these experts that are distributed globally, and they're working on increasingly sophisticated material. And unlike in manufacturing, where they have mass customization that has some variability, the variability of what a service technician needs to do every day is substantial. It's quite often that they may not see the same product they're servicing until 90 days later. So they need constant refreshes. So using 3D and virtual reality, they're able to more immersively train on that hardware without physically being next to that hardware as new equipment comes out. So for example, during the pandemic, we had a motorcycle manufacturer that came out with a significant new motorcycle release with a lot of new technology. They had 3,000 technicians that had to be trained on this. And well, they couldn't physically travel for it. So they trained in their own homes and could walk around basically a hologram of this motorcycle that's interactive from the CAD model that they could take apart and touch and practice various procedures that were presented to them. So they're able to effectively train 3,000 technicians globally without any of them physically being next to that new motorcycle. And since that worked, it's something that they had to do because of the pandemic situation. It's now a general practice because they realized how much air travel savings and time savings that they receive from doing that, and it's something that they'll continue to do. And I'll end on this story because it's a funny one, where a lot of what we talked today is about technology implementations and how that helps with sustainability, and this one's no different. This is a large home services provider and manufacturer of home appliances that wanted to have dispatch efficiency. So they were looking at remote service in their contact center and how can they receive calls or IoT alerts from customers and triage those in a way where they can either resolve the problem with the customer without sending a technician, or if you do have to send a technician, make sure that you narrow it down to the 1 or 3 possibilities so you're sending the right technician with the right information, the right parts. So they did a pilot, and it was fantastically successful with 8-figure annual savings that was extrapolated from the pilot phase. Now the problem was commercial. The contact center is in a different P&L than field service. So the contact center actually had to bulk up their operation because they were handling a little bit more, but overall there was a net enormous savings that went into field service. So it required a different commercial arrangement now within this company to do that. So the program had to bubble up a level. It ultimately went forward and was very successful. But we'll be seeing more and more of that with sustainability, not only within companies, but among companies, as far as the different investments that need to be made for a particular benefit and where is that realized and how is that commercial arrangement maintained. And before we close, I'd like to ask our panelists for some closing thoughts. Alec, off to you.
Thanks. I mean, from a closing perspective, I just think about the one thing that keeps driving me here is just the enormous opportunity, the time of opportunity that we live in. We're in the middle of remaking the global economy around sustainability. And the last time that we did anything like this as human beings was the Industrial Revolution. So we're trying to do that all in 30 years, remake supply chains, remake manufacturing. There will be enormous opportunities in building sustainable businesses, and it couldn't be more exciting.
Aaron.
Sure, great point from Alec. What I would like to add that we haven't spoken about so far is this is really important to our people. So as much as consumers care about sustainability, we're also finding that our talent cares as well. So they're looking for their employer to care about the planet and find ways to contribute to their community and make better products and all of those things. So I think it will be important to retain top talent by showing that we care about this topic and that we're investing in sustainability and energy management.
Great, great. And Chad?
And Dave, I mean, we talked across the important segments within the value chain. It reinforces the importance of a team sport, of cross organizations or outside organizations, working together. And I think the good news for all of us that it's important to the planet, but it also drives profits and performance in companies, and we don't have to weigh those off. We become a more efficient as a society and as an economic system. I'm excited about that.
I'm excited about it too. And a lot of the carbon accounting that Alec took us through is ensuring that the flywheel's in place to make sure that we're all doing this in a suitable amount of time. So we're going to get it done. We have to work together, and let's continue to share our practices together. So thank you for tuning in and hearing our point of view. Improving product sustainability matters more than ever, and it's important to act now so that you're not left behind. We're grateful to work with our partners like Kalypso and Microsoft to innovate and collaborate on making the world a better place and helping our customers do the same.